from a tank at a rate of R of T liters per hour. R of T liters per hour. Perfect. The rate is decreased as time passed. Okay, and we see that. From 8.9 to 7.5 to 6.7, clear. And values of time, 2-hour time intervals are shown in the table. Perfect. Find lower and upper estimates for the total amount of oil in liters that leaked from the tank over the interval. What is the interval? I guess 0 to 10, right? If you scroll to the right. Yes, okay. So the interval is 0 to 10. And let me copy the table. So this is T in hours. Very good. And we have 0, and we have 2, and 4, and 6, and 8, and 10. And the numbers, I wasn't able to read them, so sorry. 8.97, 7.5, 6.7, 6.4, 5.7, and 5.3. Find the upper and the lower. Okay. Perfect. So you can stop sharing now. So we do not necessarily need to graph, but I'd like to explain. So this is 0, 2, 4, 6, 8, 10. So at 0, R of T, so this is T in hours, and this is R of T. So at 0, this is 8.9. So as you see, it's decreasing. So 8.9, I'm going to say 2, 4, 6, 8. So it's this point. Then at 2 is 7.5. So 2, 4, 6, 8. Oh, 8.9, sorry, right here. So it's close to 9. And this is 10. So somewhere here. Then at 2 is 7.5. So this is 7, 7.5. And then at 4 is 6.7. And at 6 is 6.4. My unit is not very good. 5.7 and 5.3. So we see that this is, I'm not supposed to connect, and I'm not really connecting them, but I'm just showing what's happening here. Now, because it's a decreasing function, as you see, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So from 0 to 2 is the first interval, 5. So number 1, number 2, number 3, number 4, number 5. 5 intervals, subintervals. Because it's a decreasing function, the leftmost point will be an overestimate. So in order to determine the area, in other words, how much it leaked, in other words, I will be using the leftmost point for the overestimate. The overestimate will be with 5, so the area with the leftmost point 5. The under will be the area with right 5. How will that look like? Like this. And that will be an underestimate. And now for the overestimate, I will be using this height, and this height, and this height, and this height, and this height. Stop. Only 5. For the over. For the under, I will be using this height, this height, this height, this height, and this height. 5, and stop. So AL5 will be delta x, which is 2 for all 2 base times height, f of 0, plus r of 0, sorry. Everything is f in my mind, but this is r, so I have to use r. It doesn't matter. It's not important, but I have to use r. So this is r of 0 plus r of 2 plus r of 4 plus r of 6 plus nothing else. 1, 2, 3, 2, 0, 2, 4, 6. Yeah, I need 8. So, and I have the numbers. That's all I need to do. What does that mean exactly? So I will put 2 in front, which I already have. So 2, and then r of 0, 8.9, plus 7.5, plus 6.7, plus 6.4, plus 5.7, and I get a number. For the other one, the underestimate will be AR5, and I'll start with still with 2, but f of 2 plus f of 4 plus f of 6 plus f of 9 plus f of 10. So, and we'll get those numbers in a minute. So let me write this down. So so this is the over, and this is the under with 5. So this will be still 2, r of 2 plus r of 4 plus r of 6 plus r of 8 plus r of 10. So again, this will be 2, 7.5 plus 6.7 plus 6.4 plus 5.7 plus 5.3. And my calculator, who knows? Oh yes, right here. I can show this with the computer, but it's really nothing. So 8.9 plus 7.5 plus 6.7 plus 6.4 plus 5.3. No, 5.7. I'm checking my numbers. 6.7, 6.4, 5.7. So this is 70.4. And now let's see the under. 2. 7.5 plus 6.7 plus 6.4 plus 5.7 plus 5.3, and I got 63.2. So as we mentioned last time, it depends on the function. So in our case, we had an increasing function. The leftmost point will be the underestimate. The rightmost point will be the overestimate. So it depends on whether the function is increasing or decreasing. Any questions on this? Is this better? Amanda, is this okay?
Yeah, yes. Where did the 2 come from? I know you said delta x.
Base times height plus base times height. 0 to 2. 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10.
Oh, because that's the base every time. The height is what's in the parentheses. Okay.
The height, yes, and I pulled it out because it's always the same.
Yes, okay.
Perfect. Next question. Anyone? Okay, make up a function, please. Any function you want, and an interval. The difficulty will pop up when the starting point or the leftmost point of the interval is not 0. So if it's 0, it's okay. But if it's not 0, and we can work on any problem with any interval you want, but if it's not 0, it will be a little bit more cumbersome. We will get there, but it will be a little bit more cumbersome, but that's okay. So please make up a function. It can only be degree 1, 2 or 3. We are restricted. We don't have information for more than that. So, can anyone pick, please? Give us a function. You cannot give me a function with a trig function or exponential or logarithmic. You cannot do that. You can only give me a polynomial function degree 1, 2, or 3. Of course, we're not going to do degree 1. So please pick a function, a polynomial function, degree 1, 2, or 3. Anyone, please? Is anyone with me other than Amanda? Yes.
I have one.
Got it.
So, so x squared, you already have f of x, right? F of x, yes. X squared plus the square root of 1 plus 2x.
I can't, it's not polynomial. The square root is not polynomial. Oh, you mean the number?
That'd be 9.
So is it the square root of x?
It's the square root of 1 plus 2x.
No, we don't have that.
It's in our Rebel sign.
But it's it doesn't ask you to use a limit of the Riemann sum. That's not possible.
No, it just says, no, it says do not evaluate the limit.
Yes. Yeah, we cannot evaluate.
Yeah, it just says fine.
You will just plug it in. Let's work on that. It's a good one. It's a good one because it just says prepare the limit of the Riemann sum, but you cannot find the limit. I agree. That's yes. Let's work on it. It's a very good one. That's whatever it was.
It also has a domain. It says
Not a domain. It's an interval. They have to give us a closed interval. Yes. So let's write it. It's a very good one then. It was x squared plus
the square root of 1 plus 2x.
And the interval given to us was?
X is greater than or equal to 3, less than or equal to 5.
Perfect. Great job. We still have those 3 preps. Without these 3 preps, we cannot start the limit of the Riemann sum. Can anyone refresh our memory? What is the first prep?
First, we have to find delta x.
That's it. Delta x by definition is b minus a divided by n. B is 5, a is 3. So 5 minus 3 is 2 over n. Prep number 2. How do I get prep number 2? What is prep number 2?
Find xi.
Good.
So it would be 2I over n.
Careful. If we start at 0. So let's picture the interval. Let's picture the interval. So the interval is between 3 and 5. So x1 will be 3 plus delta x. x2 will be 3 plus twice delta x. x4 will be 3 plus x3 first. x3 will be 3 plus 3 delta x. x4 will be 4 plus 4. I'm sorry. Delta x. So then what will xi be? I have to start at 3.
3 plus
I delta x.
Oh, I. Okay.
So x1 is 3 plus 1 delta x. x2 is 3 plus 2 delta x. x3 is 3 plus 3 delta x. x4 is 3 plus 4 delta x. xi is 3 plus I delta x. Is this okay?
Yes.
Good. So, xi is 3 plus, as you said, I, 2i over n. This is it. This is xi. We finished with step 1 or prep 1. We finished with prep 2, which is 3 plus 2i. What is prep 3? How do we get prep 3?
We find f of xi.
Yes. So in other words, f of 3 plus 2i over n. I'm going to copy the function again here just to have it from on this page. X squared plus the square root of 1 plus 2x. And f of xi is, again, f of 3 plus 2i over n. So in here, instead of x, I have to plug in 3 plus 2i over n squared. And then plus the square root of 1 plus 2. And instead of x, I have to plug this in. Parentheses 3 plus 2i over n. Let's stop for a moment and see if we have any questions on this. So the function was blah squared plus the square root of 1 plus 2 blah. This is my blah. So it's blah squared plus the square root of 1 plus 2 times this. I wouldn't square this, but I will just distribute here. So 3 plus 2i over n squared plus the square root of, so here's what we get, 1 plus 6. But 1 plus 6 is 7, and when I distribute to the second term, I have 4i over n. That's good enough, leave it alone. Now I can write the area. Is the limit as n approaches infinity from the sum from I equals 1 through n, from delta x, which is 2 over n, times this piece. That's it. You cannot do anything else.
In the, because that came from WebAssign, so it's got the summation symbol and all that already, and it just has parentheses for us to fill in. So would I put
So
the two
you have to
in?
write 2 over n.
Okay, and then another set of parentheses inside of
Yes,
that.
yes.
Okay.
So you may have this, which is okay. It has to take it. If it doesn't take it, because it's correct. If it doesn't take it, I'll give you the points. So
Okay,
I would write 3 plus 2i over n. Again, another parenthesis squared. And plus the square root of 7 plus 4i over n. Careful how you enter it.
Oh, because I need a third set of parentheses. Okay.
Yes, so now if you don't want to use this, the third set, then we have to expand this. First term squared plus 2 times the first times the second. 12i over n plus 4i squared over n squared. Or you use another set of parentheses. So you can replace this by this. Or not. Any questions?
Yeah, it's not.